Okay, let's talk about residuals. Recall that we're talking about linear regression, so we have some data that we can show on a scatter plot, and we fit a line through it. Remember, last lecture we talked about the fitted values were the y values associated with a particular observed x value on the line. Oh, I lost my x there. Okay, so another useful concept is the length, the vertical distance between the point and the fitted value on the line. So if we take y and subtract off y hat, we can just write as y minus beta naught hat times jn minus beta 1 hat times x. Those are called the residuals. And in general, the residuals, you know, this is specific to linear regression, but this is the other equation, y minus y hat, is applicable, will be applicable throughout the rest of the semester. So just like we can think of our least squares criterion as trying to minimize the sum of the squared distances between the observed points and the fitted values, we can also think of least squares as trying to minimize the sum of the squared residuals. So residuals will tell us a lot about the fit, and in fact there's many reasons why we'd want to look at residuals, and I think probably most of you have seen these sorts of things before, where if there's some obvious component of failed model fit, when we fit the model, looking at the residuals will really highlight in on it. So if we look at the plot by itself, we include all this space here and space here that's sort of irrelevant. When you focus in on the residuals, you can focus in just on the most important parts of the plot. Residuals will also be what we use to define and obtain an estimate of our variance. We're going to cover more of this as we get to the more inferential components of regression, but we're going to first cover multivariable regression before we do it.